What if I told you a 17-year-old kid from Georgia built an engine for $70 that humiliated big block Chevys costing 50 times more? Not a typo. $70 total. This is the story of how David Pearson turned automotive engineering logic upside down and made Buick's engineers look like fools in the process. Picture this. It's a humid Saturday night at Yellow River Drag Strip outside Atlanta in 1971. The air is thick with tire smoke and racing fuel. A primer gray 1965 Buick Skylark rolls up to the starting line. No hood scoop, no fancy paint. Just rust spots and determination. In the other lane sits a pristine 1970 Chevelle SS with a built 454 big block that cost more than most people's yearly salary. The crowd laughs. They're about to witness a murder. The tree drops. Both cars launch hard, but something impossible happens. The rusty Buick doesn't just keep up, it pulls ahead. By the 60-foot mark, it's got half a car length. By the 8th mile, it's walking away. The Skylark crosses the quarter-mile finish line with a stunning 1190 at 114 miles per hour. The Chevelle, 1235 at 108. The crowd goes silent. Nobody can believe what they just saw. Behind the wheel of that Buick sat David Pearson, a skinny teenager from Marietta who worked part-time at his uncle's transmission shop. Under the hood was an engine everyone said was obsolete. A Buick 401 Nailhead he'd pulled from a wrecked 1964 Electra at Cobb County Auto Salvage 3 weeks earlier. Total investment, including the engine, gaskets, and bearings, $70. But here's where it gets interesting. The Buick Nailhead was never supposed to be a performance engine. When Buick introduced it in 1953, they designed it specifically for smooth, quiet operation in luxury cars. The name came from the valve arrangement. The valves were mounted vertically in the head and were unusually small for the engine's displacement, looking like nail heads when you removed the valve covers. Buick engineers deliberately chose small valves because they wanted high velocity through the ports at low RPMs, which created exceptional throttle response and torque for boulevard cruising. The 401 cubic inch version appeared in 1959 as Buick's answer to Cadillac's growing engines. It featured a 4.875-inch bore and 3.64-inch stroke, with those signature small valves, just 1.875 inches on the intake and 1.5 inches on the exhaust. Compare that to a Chevy 396 with 2.06-inch intake valves, or a Ford 428 with 2.09-inch valves. The Nailhead's valves were tiny. Every hot rodder knew bigger valves meant more airflow, and more airflow meant more power. It was basic math. Compression ratio on the 401 was 10.51 from the factory. Respectable, but nothing special. The camshaft was designed for smoothness with just 0.440 inches of lift and 268 degrees of advertised duration. Buick rated it at 325 horsepower at 4,400 RPM and a massive 445 pound-feet of torque at just 2,800 RPM. That torque number was the key, but nobody was paying attention. By 1966, Buick killed the Nailhead. The muscle car wars were heating up, and Buick's engineers believed their small valve design couldn't compete with the big valve, high RPM screamers from Chevrolet, Ford, and Chrysler. They replaced it with a completely new big block design featuring larger valves and modern wedge combustion chambers. The Nailhead was officially obsolete. Junkyards filled up with them. You could buy a complete 401 for $30 to $50. Enter David Pearson. Pearson didn't have money for a built 454 or Ford 40. He had $70 he'd saved from fixing transmissions. But he had something more valuable. He understood physics. While everyone else was chasing peak horsepower numbers, Pearson recognized that drag racing was about area under the curve. It wasn't about making 500 horsepower at 6,500 RPM if you couldn't use it. It was about making usable power from idle to redline. The Nailhead's small valves that everyone mocked, they created incredible port velocity. Think of it like water through a garden hose versus a fire hose. The garden hose shoots water much faster and farther because of the restriction. Same principle with the Nailhead's ports. At low and mid-range RPMs, when bigger engines were still building velocity, the Nailhead was already moving the air-fuel mixture at optimal speeds. This created a ramming effect that packed more mixture into the cylinders than you'd expect from the valve size alone. Pearson understood this. He also understood that the Nailhead's valve arrangement created natural swirl in the combustion chamber. The vertical valves directed the mixture in a circular pattern that promoted complete combustion. You could run more timing advance without detonation. You could run leaner mixtures without misfires. It was accidentally brilliant engineering that Buick never fully exploited. His $45 Junkyard 401 had 67,000 miles on it. The cylinders showed normal wear, about 0.03 inches over standard bore. Instead of boring it out like everyone would do, Pearson honed the cylinders with a dingleberry hone just enough to break the glaze. He measured bearing clearances with plastigauge he borrowed from his uncle's shop. Mains were at 0.025 inches, rods at 0.02 inches. Perfect. He didn't touch them. The magic happened in the details. Pearson pulled the heads and spent 3 days with a die grinder and carbide burrs he'd bought at a pawn shop for $8. He didn't make the valves bigger. That would have killed the velocity. Instead, he smoothed the short turn radius where the port turned toward the valve. He matched the intake manifold to the head ports perfectly. He knife-edged the valve guides to reduce turbulence. Total material removed, maybe 3 ounces. But it reduced pumping losses by an estimated 15%. For the cam, Pearson couldn't afford a custom grind. He found an old Iskandarian E2 NASCAR grind at a swap meet for $12. It was designed for a small block Chevy, but the Nailhead used the same base circle diameter. The cam specs were aggressive, 0.520 inches of lift with 292 degrees of advertised duration. In a Chevy, this would have been mild. In the Nailhead, with its small valves and high-velocity ports, it was perfect. The increased lift and duration worked with the port velocity to create a supercharging effect. The real genius was in the carburation. Everyone was running Hollies because that's what you did. Pearson found a Rochester Quadrajet from a 1968 Pontiac at the same junkyard, $15. The Q-Jet had tiny primaries for excellent throttle response and huge secondaries for top-end power. But more importantly, it had incredible metering precision. Pearson rejetted it using drill bits, number 73 primaries and number 77 secondaries. He shimmed the accelerator pump with washers from his uncle's coffee can of hardware. Total cost for jets and washers, $0. Here's where Pearson's understanding went deeper than most professional engine builders of the era. The Quadrajet's variable secondary air valve meant it could match airflow to engine demand perfectly. With the Nailhead's high port velocity, this created an ideal pressure differential across the boosters at every RPM. The engine never went lean, never went rich, just stayed in the sweet spot where maximum power lived. For the exhaust, Pearson understood that the Nailhead's small exhaust valves created high exhaust velocity, which improved scavenging. He built his own headers from electrical conduit, 2-inch EMT thin-wall tubing he got from a construction site dumpster. He calculated primary tube length using formulas he found in a hot rod magazine at the library, 32 inches from the exhaust valve to the collector. He welded them up with his uncle's stick welder using 1611 rod. They looked terrible. They worked perfectly. The ignition system showed more clever thinking. Pearson found a Delco transistor ignition module from a wrecked 1963 Corvette fuel injection car. These were rare and expensive new, but the junkyard didn't know what it was. $3. He adapted it to the Nailhead's distributor, advanced the timing to 38 degrees total, and curved it to come in fully by 2,800 RPM. The hotter spark let him run a wider plug gap, 0.045 inches, instead of the stock 0.35. More gap meant bigger flame kernel, which meant better combustion, which meant more power. Now here's the kicker. At Atlanta Dragway's test and tune night, Pearson's first pass was a disaster. The engine stumbled off the line, recovered, then fell on its face at the top of first gear. 1420 at 89 miles per hour. Spectators laughed. Another kid with junkyard dreams. But Pearson knew exactly what was wrong. The Quadrajet secondaries were opening too early. He adjusted the air valve spring tension with a paperclip bent into a tool. Second pass. 1345 at 101. Still not right. The converter was too tight. Pearson didn't have money for a new one, so he did something insane. He drained 2 quarts of transmission fluid and added 2 quarts of diesel fuel. Diesel fuel is thinner than ATF, which makes the converter slip more, which raises the stall speed. It's terrible for the transmission long term, but for a few passes, it works. Third pass, 12.61 at 109, getting closer. The launch was better, but still soft. Pearson remembered something he'd read about Smokey Yunick's NASCAR tricks. He drilled a 1/8 inch hole in each header collector right before the merge. This created a low-pressure area that pulled extra exhaust out during valve overlap. It also leaned out the mixture slightly at launch, which reduced bog. Fourth pass, 12.22 at 112. He was onto something. The diesel fuel in the transmission had raised the stall speed from 1,800 to about 2,400 RPM, right where the Nailhead's torque curve went vertical. But he needed more. He removed the fan and alternator belt. He drained the cooling system and ran straight water with dish soap as a surfactant for better heat transfer. He pulled the air cleaner and ran open carb. Fifth pass, 1197 at 113. The crowd was paying attention now. This rusty Buick with conduit headers and spray bomb primer was running times that $5,000 engines struggled to match. Pearson made one more adjustment. He noticed the engine pulled harder in the cool night air. Colder air is denser, which means more oxygen per cubic foot. He packed bags of ice around the intake manifold between runs. The ice dropped intake air temperature by 20 degrees. Final pass of the night, 1190 at 1:14. Word spread fast through Atlanta's racing community. The next weekend, Pearson showed up at Yellow River for Saturday night eliminations. His first-round opponent? A local heavy hitter with a professionally built 454 Chevelle that had won 3 straight weekends. The Chevy had Brodix aluminum heads, a Crane roller cam, and a Holley 850 double pumper. Easily $3,000 in the engine alone. The race wasn't even close. Pearson's Nailhead launched like it was on a catapult. The instantaneous torque from those high-velocity ports hit the converter perfectly. The Buick was a car length ahead before the Chevelle's driver could blink. By half-track, it was over. Pearson's 1192 to the Chevelle's 1228. The Chevy owner demanded to look under Pearson's hood, convinced he was hiding nitrous or something. All he found was a greasy Nailhead with conduit headers. What made this possible? Let's dive into the physics that Pearson intuitively understood, but most racers missed. The Nailhead's combustion chamber was a modified pent roof design with the spark plug centered. This created nearly ideal flame propagation. The flame front traveled equal distances to all edges of the chamber. Combined with the swirl from the vertical valves, this meant near-complete combustion. Typical engines of the era left 5 to 8% of the fuel unburned. The Nailhead, when tuned right, left less than 3%. That's free power just from combustion efficiency. The small valves everyone hated had another advantage. They were lighter. A Nailhead intake valve weighed 89 grams versus 124 grams for a big block Chevy valve. Less mass meant less valve float at high RPM. It also meant the valve springs didn't have to work as hard, which reduced parasitic losses. Pearson's junkyard valve springs were still making full pressure at 6,000 RPM when most stock springs were dancing. Port velocity is measured in feet per second. Optimal velocity for naturally aspirated engines is between 240 and 280 feet per second at peak torque RPM. Big block Chevys with their huge ports typically saw 180 to 200 feet per second at 3,000 RPM. The Nailhead, 265 feet per second at the same engine speed. This high velocity created a pressure drop that actually pulled mixture into the cylinder rather than just pushing it. It's called the Bernoulli effect, and it's free supercharging if you understand it. The quadrajet carburetor Pearson chose was another physics lesson. Unlike Holley's with their fixed venturi design, the Q-jet used variable venturies that maintained optimal pressure drop regardless of airflow. At 3,000 RPM, the primaries were flowing 250 CFM with a pressure drop of 1.5 inches of mercury, perfect for signal strength. At 5,500 RPM with the secondaries open, it flowed 750 CFM with the same pressure drop. A Holley would have either been too big at low RPM or too small at high RPM. The Q-jet was right-sized everywhere. Pearson's conduit headers were accidentally brilliant. Professional headers of the era used thick wall tubing, typically 0.065 to 0.095 inch wall thickness. The EMT conduit was 0.042 inch wall. Thinner walls mean less thermal mass, which means they heat up faster, which means exhaust velocity increases quicker. The faster the exhaust gets up to temperature, the better the scavenging effect. Pearson's cheap headers actually worked better than expensive thick-wall versions for drag racing. The diesel fuel in the transmission trick came from circle track racing. Diesel has a lower viscosity than Type F automatic transmission fluid, about 2.8 centistokes versus 7.5 for ATF at operating temperature. This thinner fluid creates more slippage in the torque converter, effectively raising the stall speed. It also reduces pumping losses in the transmission by about 8%. The downside? It destroys clutch friction materials within a few hundred passes. But Pearson only needed it to last one night. Think about that for a second. This 17-year-old kid with no formal engineering education understood fluid dynamics, combustion theory, and thermodynamics well enough to extract 425 horsepower from an engine everyone said was worthless. He did it with junkyard parts and hardware store supplies. His total investment, including gas to drive to the track, under $100. The established racers didn't know what to make of Pearson. He kept showing up with that ugly Skylark and kept winning. He'd collect his trophy and prize money, usually $200 to $500, and disappear. No trailer queen, no crew, just him, and sometimes his younger brother. He'd drive the car home on the same tires he raced on. By the end of summer 1971, Pearson had won 11 races and placed second 4 times. His total winnings? About $4,000. Not bad for a $70 engine, but more importantly, he'd started something. Other racers began hunting junkyards for nailheads. Suddenly, those obsolete engines nobody wanted were selling for $200, then $300. The Buick racing community took notice. Max Balchowski, famous for his old Yeller race cars, called Pearson after hearing about his success. He wanted to know the combination. Pearson shared everything, no secrets, no magic, just physics and clever thinking. Balchowski built a Nailhead using Pearson's principles for his wife's street car. It ran 1280s with full exhaust and a mild cam. Hot Rod magazine sent a reporter to Atlanta in September 1971. They wanted to document this miracle Nailhead. The reporter, Gray Baskerville, couldn't believe what he found. No machine shop, no flow bench, no dynamometer. Just a kid with grease under his fingernails and a notebook full of calculations. Pearson had derived his own formulas for port velocity based on observations and trial and error. The magazine article, published in December 1971, changed everything. Suddenly, everybody wanted to build a Nailhead. Speed shops that had been scrapping them started rebuilding them. aftermarket companies rushed to develop performance parts. Mondello Performance introduced the first aluminum heads for nailheads. Crower cams created specific grinds. Offenhauser built tunnel ram intakes. But here's the thing about Pearson's success that most people missed. It wasn't about the nailhead being some secret weapon. It was about understanding what you had and maximizing it. While everyone else was trying to make their engines into something they weren't, Pearson worked with what the nailhead naturally wanted to do. He didn't fight the small valves, he used them. He didn't curse the weird combustion chambers, he optimized them. Buick engineers, when they heard about Pearson's success, were embarrassed and intrigued. They'd abandoned the nailhead thinking it couldn't compete in the horsepower wars. They'd never considered that maybe they were fighting the wrong war. Drag racing isn't about peak horsepower on a dyno. It's about average horsepower under the curve, and more importantly, it's about putting that power down effectively. One Buick engineer, Tom Rutter, visited Pearson in early 1972. He wanted to understand what this teenager had figured out that Buick's entire engineering department had missed. After spending a day with Pearson, going through his notebooks and examining the engine, Rutter reportedly said, "We spent millions developing the new 455, and this kid proved our old design was better for actual racing. We were solving the wrong problem." The nailhead's reputation completely reversed. What had been a laughingstock became a cult hero. Prices for 401s and 425s skyrocketed. By 1973, you couldn't find a complete nailhead for under $500. The same engines that had been scrap metal 2 years earlier were now gold. Pearson had single-handedly created a market, but Pearson himself moved on. He used his winnings to pay for technical school, eventually becoming an aerospace engineer. He worked on the space shuttle program, applying the same unconventional thinking that had made his nailhead successful. When asked about his racing days, he'd say, "The nailhead taught me that conventional wisdom is often conventional stupidity. Question everything, understand the physics, and trust the data." The Skylark. Pearson kept it until 1975, then sold it to a collector for $8,500. The new owner immediately pulled the engine to put it in a lighter car. At teardown, they found something amazing. Despite 2 years of brutal drag racing, the bearings still looked perfect. The cylinder walls showed no measurable wear. The valve springs were still within spec. That $70 junkyard rebuild had survived what would have killed most $5,000 race engines. Today, nailheads are legendary in drag racing circles. A properly built 425 nailhead can make over 600 horsepower while maintaining the incredible torque curve that made them famous. They're particularly popular in nostalgia racing, where their distinctive valve covers and unique exhaust note make them instantly recognizable. A good 425 core sells for $3,000 or more. Modern engine builders have confirmed what Pearson discovered intuitively. Computational fluid dynamics simulations show that the nailhead's port velocity was indeed optimal for street and strip applications. The vertical valve arrangement does create beneficial swirl patterns. The combustion chamber design, while unusual, is remarkably efficient. Everything Pearson claimed was right. The aftermarket has exploded for nailheads. You can buy aluminum heads with bigger valves, but interestingly, many racers stick with the stock valve sizes. They've learned what Pearson knew. It's not about the size, it's about the velocity. You can get stroker cranks to take displacement to 406 cubic inches, roller camshafts, fuel injection conversions, even supercharger kits. The engine Buick killed because it couldn't perform has become a performance icon. Pearson's story spread beyond just nailheads. It became a legend in bench racing sessions about the kid who outsmarted the establishment. It inspired countless young racers to think differently, to question conventional wisdom, to understand the why behind the what. His approach, using physics and observation rather than just throwing money at problems, influenced a generation of racers. The comparison to modern engines is striking. Today's LS engines make power through efficiency, not brute force. They use smaller ports for velocity, advanced combustion chambers for complete burn, and sophisticated valve timing for optimal cylinder filling. Sound familiar? They're using the same principles Pearson applied to the Nailhead, just with modern technology. In many ways, Pearson was 50 years ahead of his time. Engine builders who've tried to recreate Pearson's exact combination have found something interesting. Even with the same parts and modifications, they can't quite match his times. There was something about his specific engine, his specific combination, his specific understanding that created magic. Some theorize his junkyard 401 had slightly different casting dimensions that created perfect port alignment. Others think his conduit headers accidentally hit a resonance frequency. The truth is probably simpler. Pearson understood his engine intimately and adjusted everything perfectly for his specific combination. Racing historians mark Pearson's summer of 1971 as a turning point in drag racing. It proved that money couldn't buy victory if you didn't understand the fundamentals. It showed that obsolete technology might just be misunderstood technology. Most importantly, it demonstrated that innovation doesn't always come from professional engineers with unlimited budgets. Sometimes it comes from a teenager with $70 and a different way of thinking. The Nailhead's influence extends beyond drag racing. The engine's torque characteristics made it perfect for jet boats, where instant thrust matters more than peak horsepower. It became popular in mud racing, where the ability to maintain power at low RPM in thick mud was crucial. Even in Bonneville land speed racing, where you'd expect high RPM screamers, Nailheads found success in classes where reliability mattered more than ultimate power. Pearson himself, now retired from aerospace, occasionally appears at Buick meets. He's a hero to Nailhead enthusiasts, the kid who saved their engine from the scrap heap. He still has his original notebooks with all his calculations and observations. They've become something of a holy grail for Nailhead builders, containing insights that modern technology has only recently validated. When asked what advice he'd give to young racers today, Pearson says, "Stop copying what works for others. Understand what you have, understand the physics, and exploit the advantages everyone else ignores. The winning combination is rarely the obvious one, and for God's sake, stop throwing money at problems before you understand them." The legacy of that $70 Nailhead goes beyond just racing success. It changed how people thought about engine development. It proved that abandoned technology might have untapped potential. It showed that understanding trumps spending every time. Most importantly, it demonstrated that innovation doesn't require massive resources, just intelligence, determination, and the courage to think differently. Today, when someone builds a Nailhead for performance, they're following the Pearson blueprint whether they know it or not. Small tube headers for velocity, careful port work without enlarging, camshafts that complement the port velocity, carburetors sized for the application, not the ego. It's become the standard approach, but in 1971, it was revolutionary. The story reminds us that engineering excellence isn't always about the newest, most expensive, or most popular solution. Sometimes it's about understanding fundamental principles and applying them cleverly. Pearson didn't reinvent the Nailhead. He simply understood it better than its own creators. He saw potential where others saw obsolescence. He found performance where others found problems. That rusty Skylark with its $70 engine embarrassed the establishment and created a legend. It proved that in racing, as in life, understanding beats spending, physics beats fashion, and sometimes a teenager with a different perspective can see what experienced engineers miss. The Nailhead wasn't obsolete. It was just waiting for someone who understood its potential. What's your take on this story? Have you ever found hidden performance in something everyone else overlooked? Drop a comment below and share your own tales of junkyard glory. And if you enjoyed this deep dive into one of racing's greatest David versus Goliath stories, make sure to subscribe. We're just getting started with stories of engineering rebels who changed the game with creativity instead of cash. Until next time, keep questioning conventional wisdom, and remember, sometimes the best solution is the one everyone else abandoned.